Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to take the feedback or the concurrence regarding the quality of audio as well as video. If it is perfect, just write perfect over the live chat and then we are ready to go. This is nothing but the 14th lecture over the series of the engineering mathematics, where I used to take the problem which have come recently, that is in GATE year of 2021, and with the help of those problems we are building our concept for the year of 2022. So approximately 55 number of problems have been taken till the lecture number 13th, and the agenda behind today's video, I would be taking around 4 to 5 number of problems again which have come in GATE year of 2022, specifically from the subject called engineering mathematics. Yes. So without getting delayed, let me straight away jump into the question itself. Just a minute. Just a minute. So tell me about the quality of video as well as audio. If it is perfect, just at least write perfect, so at least I'll have the fair idea that the quality as well as quality of video as well as audio is properly transmitted from our side. So the first question comes from the page number 27. The first question comes from page number 27. See what this problem states. See, this has been a problem from mechanical engineering year of 2021, and keep in mind the mechanical engineering had the two number of papers, forenoon and afternoon. So this problem have come in forenoon session. Let me read what the problem states. The Dirac delta function del of within the bracket t minus of t naught for t where t naught belongs to all real numbers has the following property: integration from a to b of phi of t delta of t minus of t naught dt is equals to of phi of t naught when the t naught is in between a comma b, otherwise 0. The Laplace transformation of the Dirac delta function del of t minus a for a greater than 0 is, we need to get the Laplace transformation of the delta function t minus of a, and which is equals to of f of s, which is equals to of f of s. So tell me what would be the best most answer. Anyways, the electrical and electronics people who might be following my lecture, they might be finding bit amusing, sir, how the problem have come from the concept of the Laplace transformation in engineering mathematics. So you need not to have any amusing sort of thing. My dear friends, in mechanical, the Laplace transformation has been a part of the engineering mathematics itself. That is why they used to have few number of problems from the domain of Laplace transformations also. Anyways, once you'll recall how the delta function has been defined, I am not going into the detailed analysis of the delta function, but it has been clearly given. The delta function has been defined in such: the integration of phi of t del of t minus of t naught dt from the integration a to b has been defined as a phi of t naught itself. Anyways, it has been its basic definition of the delta function itself. I am not going into the detailed study of the signal called delta function. Put together, you can assume in this way, you have been dealing with a standard delta function. So you have been dealing with the standard delta function. Delta function. In this problem, they were wanting you to calculate the Laplace transformation of del of t minus of a. Obviously, I can apply one of the important property which is getting followed by the Laplace. What used to be that? Laplace of function which had the shifting in time domain can be simply written as e to the power of minus of as of f of s. What is the f of s over here? The f of s is a Laplace transformation of f of t, and similarly, as there has been shifting of a minus a, the e to the power of minus as would get multiplied with the f of s. It's quite simple as this. Again, you will see you were searching for the Laplace transformation of the delta of t minus a. That means it is a Laplace transformation of del of t which was got shifted by a. So first focus over the Laplace of delta of t, which is equals to of 1, and hence if you will calculate the Laplace of t minus of a, which would be simply e to the power of minus s, which would get multiplied with 1. And the result what we are getting is simply going to be e to the power of minus as. Yes. So what would be the best most answer? The best most answer is going to be option D. Again, let me recall what the problem was given for. My dear friends, we had a standard delta function and taking the reference of a standard delta function, you had to find the Laplace of delta of t, where the t got shifted by a. T has got shifted by a. So first we'll be focusing over the Laplace of del of t, which is simply equals to of 1. And now as there would be a shifting of minus a, so definitely e to the power of minus as would get multiplied with the f of s, where the f of s has been 1 for the given delta function. Once we are done with this, we would move into the next question. The next question comes from the page number 31. Just a minute. Next question comes from page number 31. Here goes the next question. Yes. Let me take this problem into the working board for the better understanding, and we'll try to smash that problem there itself. Let me bring this problem into the working board. This problem goes into the working board, yeah. Just a minute. Yeah. This has been the second problem of the day. See what the problem states. Consider the following differential equation. 1 plus y, which is getting multiplied with the dy by dx, is equals to of y. The solution of the equation that satisfies the condition y of 1 is equals to 1 is, there were the 4 different options were attached along with this problem. It has been a type of MCQ. That means you will be having only and only one option as a correct option. My dear friends, whenever you deal with the differential equation, and here it has been clearly known to us, we are talking about the solution of the differential equation, whether it's a general solution or whether it's a particular solution. My dear friends, the initial condition has clearly been allocated along with this problem, so obviously we are going to discuss about the particular solution. See, whenever you have been dealing with the first order differential equation, first look into this problem whether it's the first order of differential equation or not. Obviously, as you can see, the derivative component has been an order of 1, so obviously it has been a first order differential equation. Whenever you look into the solution of the first order differential equation, my suggestion would be first start smashing the problem using the concept of variable separable. What does it mean by the variable separable? That means the variables are able to get separated or not. Like here you can see the function of x got separated with the dx, and similarly function of y got separated with respect to the dy. Whether it's possible or not, if it is possible, try to smash this problem using this concept itself. If you are not able to separate their functions in terms of their independent derivative and dependent derivative, so what I would do, I would go into the next methodology, and there we would try to search whether they have been forming a type of homogeneous equation or not. What does it mean by the homogeneous equation? The structure of the homogeneous equation used to be dy by of dx is equals to of f of xy divided by of g of xy, where the degree of numerator, or the degree of the numerator of each and individual term has to be very same as the degree towards the denominator side. In that case, what we do, I used to keep y is equals to of v times of x, and thereafter the dy by of dx would become v plus of x dv by dx. It would be fed over here, and once we'll be substituting y is equals to vx, by default this problem would get converted in a form of variable separable. If the problem is not getting smashed with the homogeneous equation, straight away I would suggest to go into the form of Bernoulli's form of the linear differential equation. Anyways, once you'll see the differential equation itself, you'll get to know whether it's a form of Bernoulli differential equation or not. How the Bernoulli differential equation looks like? It used to be dy by of dx plus of p. It has to be a function of independent variable x itself. Here goes y, and towards the right hand side, you should have a function which must be a strict function of x, or maybe constant also. And even sometime you may have reducible to the Bernoulli's form of the linear differential equation, which we have seen earlier, where what we used to have the multiplication. Just a minute, let me copy this out. How used to be the structure? The structure used to be, what they would be doing, deliberately they would be multiplying y to the power of n towards right hand side. Till this point, each and everything is clear or not? What I am saying, whenever you have the problem which are related to the first order differential equation, I must be applying this methodologies in process. First we'll see whether we are able to smash the problem using the variable separable or not. We are not, then definitely we will move ahead with the homogeneous, then we will go into the Bernoulli's form, the linear differential equation, and even we are not able to apply this, so definitely we will move into the reducible to the Bernoulli's form, the linear differential equation. And definitely as far as the GATE syllabus is concerned, the question do come into GATE. Definitely definitely the problem would get smashed in either of this method. Most of the time the problem do come from this, sometime this, and even sometime this. Rarely problem do come from this situation. So again we had this problem. The differential equation is clearly known to me, which is 1 plus y dy by f dx is equals to of y. Tell me whether this problem can be resolved in a form of variable separable or not. What does it mean by the variable? Variables can be separated or not. Yes, it can. It can. See, dy has been over here. What you can do, the dy can be shifted towards left hand side. Obviously it would come towards denominator, so it would become 1 plus of y divided by y getting multiplied with y, and the dx would get shifted towards right hand side, it would get multiplied with 1, so obviously it would be just dx. How the structure had been? The structure had been 1 plus y divided by y, which is the f of y getting multiplied with the dy, and similarly towards right hand side 1 is getting multiplied with the dx. Put together f of y dy is equals to of f of x dx. Definitely it has been a problem of variable separable. Easily you would be able to address this problem well using the variable separable. Could you understand from where our name has come as a variable separable? The variables are able to separate in terms of their derivatives. Yes, so let me bring this problem into the next working board. The problem is 1 plus y dy by dx. 1 plus y, just a minute, let me write 1 plus y dy by of dx, and let's see what was next, is equals to y. Yes, what I would be doing, definitely I would be arranging the problem in such it must be following the variable separable technique. So what I would be doing over here, 1 plus y would remain 1 plus y. The y has been shifted towards downside, it would become 1 plus y divided by y getting multiplied with the dy, and the dx is getting multiplied with 1. Simply it's gonna be dx. What I would be doing now, I would be multiplying, I would be integrating both other sides. So whenever you talk about the general solution of reducible or variable separable form of the differential equation, we take integration both other side. So what happens over here? The integration has to be taken for 1 plus y divided by y. For the better understanding, what I would be doing, see, y would be taken separately with the 1, y would be taken separately with the y. So here it would be 1 divided by y plus of 1 over dy, and similarly towards the right hand side there would be the integration again over the dx, and here one arbitrary constant c has to come. Why? See, when you were talking about the antiderivative or the integration, see, why this c comes? Let me give an example. Like you have an equation y is equals to of 2x plus 2, y is equals to of 2x, y is equals to of 2x plus 3. See, they have been a simple function. With the help of this function, if you want to derive the differential equation which satisfies this simple function, what you will be doing? You will be taking differentiation both of the side with respect to the x. Once you take the differentiation both sides with respect to the x, it would become dy by dx, and it has become just 2. Similarly here also it has been dy by of dx is equals to 2, and for the next equation also it has been dy by dx is equals to 2. But my dear friends, the general solution when you will be getting from this differential equation, or just say one thing, if you want to get the solution back from this differential equation, if you take the integration both of the side, for the time being let has been dy of 2 times of dx. Once you will take integration both of the side, the dy would become y, and similarly 2 dx would become 2x, but you could not retrieve 2 over here, you could not retrieve 0 over here, you could not retrieve 3 over here. How will you retrieve them? I will retrieve them by keeping those constant as an arbitrary constant. And anyways, why the arbitrary constant has been taken as c? Because either it is 2, either it is 0, either it is 3, either it is 4, either it is 10 to the power of 6. Keep in mind the nature in differential equation is not going to change with the value of c. No, nature of the differential equation is not going to change with value of c. If you want, I can give an example. For that, let me draw a xy plane. For the time being, I had a straight line having a slope as positive. Let's take the equation has been y is equals to of 2x plus of 3. It has been crossing 3. Similarly, now if you have drawn a next equation, next straight line, again they have been parallel to each other, and as the slope is same, the m would be very same, and let's take it has been passing through 1 over the y-axis. It has been 2x plus of 1. 2x plus of 1. Both of them has been parallel. And if we'll be talking about their derivatives, the derivatives would be 2. Derivatives would be 2. So one thing is quite sure. If you take the derivative of the first function, that is also 2. If you take the derivative of the second function, that is also 2. That is also 2. That means they are not at all depending over the values of c. So that is why what we do, when we take the reversal process is nothing but the getting the general solution of the differential equation. By default, we used to apply a c. How many times the integration has been done? The same time the c has to be taken into the place. C has to be taken into the place. Could you understand what I am saying? So the same thing has been happening over here. We were talking about the general solution of the differential equation. Obviously, using the variable separable technique, what I did, the y has been transferred toward left hand side. So obviously, it become 1 upon y plus of 1 getting integrated over the y domain, and here becomes the integration of dx plus of c. So may I know what should be the integration of 1 upon y? It's simply going to be ln of y. Integration of 1 over dy, obviously it's simply going to be y, and here it becomes x plus of c. X plus of c. And once you'll visualize this problem carefully, you'll get to know the value of y at x is equals to 1 has been precisely 1. The value of y at x is equals to 1 was precisely equals to 1. So for getting the particular solution, definitely I would be feeding x is equals to 1, and similarly I would be feeding y is equals to 1. Let me do so. So here it becomes ln of 1 plus of y becomes 1 at x is equals to 1 plus of c. Keep in mind ln of 1 is simply 0. Not only ln of 1, even log base of a is equals to 1 is always 0. It becomes 0. It becomes 0. Even 1 goes out, the value of c has been precisely be 0. The c has been precisely be 0. So let me drop these values over here. Ln of y would remain as it is, plus of y is equals to c, and keep in mind the c has been found to be 0, which was with the help of this. So the best most answer what we are getting is simply going to be a. Simply going to be a. So till this point, probably each and everything must be clear to all of us. Yes, you can shift ln a bit. No, you can shift ln a bit. You yourself would be able to get that value. There is no problem as such. Yes, yes, no. So the best most answer what we are getting is going to be this. So till this point, probably each and everything must be clear to all of us. If you don't understand, do one thing. Keep y as it is. Here it goes x minus of y. It would become e to the power of x minus of y. Yes. And here it becomes y is equals to, it can be written as e to the power of x divided by of e to the power of y. Once you will be shifting e to the power of y towards the left hand side, the result what we get, it's going to be e to the power of y getting multiplied with y is simply equals to of e to the power of x. E to the power of x. Yes, the answer is going to be a. I know this is the point where many of the students would do mistake. They will come till this point and probably they may not be able to get till the correct option. No, my dear friends, you just have to apply the basic theorems of the log natural, and similarly of the exponent, you will be getting the exact most answer. So the best most answer for this problem was option A. Option A. Yes. In the same sequence, let me move forward and bring it to the next question in front of you. The next question comes from the page number, just a minute. Why this problem happens again and again? Let me see that. Anyways, I need to go back once again. Just a minute. The next question is coming from page number 35 and 36. So here goes the next question. Yes, one of the well-designed problem. This problem have come from the concept of the numerical method, and using the Newton-Raphson method, we had to guess the root of this cubic equation x cube minus of x minus of 3 is equals to 0. Is equals to 0. So let me try this problem out, and we'll try to get this answer with the optimal amount of steps. See what this problem states. We'll try to understand what this problem exactly wants to speak. Find the positive real roots of x cube minus of x minus of 3 using the Newton-Raphson method. If the starting guess x0 is 2, the numerical value of the root after the 2 iteration x2 is rounded off to the 2 decimal places. And yes, it has been a problem from the mechanical engineering. My dear friends, before jumping into the solution of this problem, I would suggest have a bit idea about the Newton-Raphson method. Anyways, first go behind its theoretical understanding. The numerical method, sorry, Newton-Raphson method is used to solve the what? Algebraic equation and transcendental equation. What does that mean by the algebraic equation? The algebraic equation is nothing but the equation which was being fabricated by comparing a certain polynomial with 0. Yes, it has been a polynomial with the degree of 3, and yes, it has been compared with the 0. And what does it mean by the transcendental equation? The transcendental equation is a type of nonlinear equation which consists at least one log natural or the logarithmic function, anti-logarithmic function, trigonometric functions. So anyways, as far as this problem is concerned, it has been a type of algebraic equation. Obviously, Newton-Raphson method can be used to identify its real root. Till this point, probably each and everything must be clear to all of us. Now let me go behind the derivation part of the Newton-Raphson. See, at very beginning what I did, I took an assumption. Let's take the function has been f of x. The function, this x cube minus of x minus of 3 has been f of x, and let's take the f of x look something like this. Yes, it's just merely assumption. I am not going to draw x minus 3 exactly, but yes, it has been your assumption f of x. And the initial approximation has been clearly given. The initial approximation used to be taken as x naught. It has been taken as x naught. Yes, x naught. Yes. Now, with the help of x naught, you had to find its better approximation. What does that mean by the better approximation, my dear friends? You had to find the root of x cube minus of x minus of 3 near to x naught, which has been 2, which satisfies this equation. That means by default the left hand side becomes 0, and which is very same as the right hand side. Yes. Finding the root, that means finding the value of x which satisfies this equation. At very beginning it has been clearly given. The initial guess was at x naught, which is equals to of 2, and the person who have gone through few number of questions related to the Newton-Raphson, they must be knowing it. Exact one initial guess is required. Until and unless you do not have exactly one starting guess, you would not be able to find the exact most answer, and that is why exactly one guess has been provided along with this problem. That has been x naught is equals to 2. What used to be the formula? I would say, let me show how the formula has been derived. If you use the Taylor series expansion, see what I am saying. If you use the Taylor series expansion, see the x naught was the first approximation. What it indicates? It indicates if you'll feed x as a x naught, the value won't be 0. Why? If the value becomes 0 straight away, that means the x naught is the actual root. So what you would be doing over here? Sir, why don't we displace a bit with the amount of h from x naught such that the function f of x naught plus h becomes 0? Could you understand what I am saying? I am just focusing over the derivation part of the Newton-Raphson method, because I know many of these students used to forget this equation, and end of the day they'll end up with the wrong answer. What I am saying, the initial approximation has been x naught is equals to 2. That means if you want to search the actual root of this cubic equation, you can search near to the x naught. So what I did, I assumed near to x naught, if I displace by the amount of h, I used to reach into the actual location of root, and if you have reached to the actual location of the root, definitely once you will be feeding the location over the function, the worth of the function would become 0. So till this point, probably each and everything must be clear to all of us. And now let me focus over this problem and just do its Taylor series expansion. See, Taylor series expansion has been the part of the Newton-Raphson. What used to be the Taylor series expansion? So here it would become f of x naught plus of h f dash of x naught divided by f1 factorial, and similarly you will be having higher order of its value. Yes, higher order of h. But what I am going to do, I am just going to drop the all of the higher order, or I can say I took only and only its linear approximation. May I know when the linear approximation would be a true approximation? That would be a true approximation only if mod of h is much smaller than 1. Mod of h is much smaller than 1. Why? Because in future it's going to be h square, h cube, h to the power of 4, and if the value of h is very near to 0, what is happening? Their values are continuously decaying down, so obviously they can be dropped easily. They could be dropped easily. So till this point, probably each and everything must be clear to all of us. Next, what we would be doing over here? See, so my agenda is to get the value of h. So what would be the h over here? See, the function's worth at x naught plus of h has been 0. So obviously f of x naught would be shifted towards left hand side, which is simply f of x naught divided by it would be f dash of x naught. So if you'll be talking about the first approximated root, which has been near to x naught, which has been x naught plus of h, why don't we call it x1? Would have the worth is equals to of x naught, and similarly the value of h has been clearly known to me, which has been f of x naught divided by of f of x dash of naught, Yes. In the different way, you can say I have taken the linear approximation of this function. So at very beginning, what I did, I took the tangent over the point. Which point it is? Its worth of abscissa has been x naught. The worth of ordinate has been f of x naught. We took the tangent over this point. What does that mean by the tangent? Tangent used to be a straight line which would be just kissing this point and you'll just be crossing it. Yes. Now, this straight line crosses through the x-axis. I am going to take this as a first approximation, which is nothing but the x1, which has been x naught plus of h, which has been found to be x naught minus of f of x naught divided by f dash x naught. Next, what I would be doing, I would be taking the next approximation. Here I would be drawing the new tangent. End of the day, you will be reaching to the actual root most. Yes. So could you understand what exactly I wanted to say? Although if you'll say how much time this problem is going to take, so probably within 40 to 50 seconds, you would be able to deal this problem comfortably. But what I am saying, our agenda is to teach the well-defined concepts from each and individual problem. That is why I am going into the surgery part of this problem. The problem has been the problem of the Newton-Raphson method. In Newton-Raphson method, what we do, we used to take only one initial approximation, and that approximation has been x naught is equals to 2. Taking the reference of x naught is equals to 2, we are going to find its first better approximation. How will you get the better approximation? Keep in mind, you can draw the tangent over this point, and let's take this f of x has been approximated by a straight line. So far you were looking, the f of x is going to cross to the point somewhere here, and that would be your actual root. Rather having the f of x in nature itself, I have approximated f of x as a straight line, and now we are seeing where this straight line is going to cross the y-axis, the y is equals to 0 axis, and that has been your first approximation, so on and so forth. You would be keep doing. Now you yourself would be able to understand. So in general, this equation can be written as x1 was taking the reference of naught, that is why it has been x naught minus of f of x naught f dash x naught. Similarly, if you would be finding the second approximation or the better approximation taking the reference of x1, definitely it would become x2, it would become x1, it would become x1, it would become x1. Obviously it has been. So in general, if we'll talk about the algorithm which we use during Newton-Raphson approximation, it's simply going to be x of n plus 1 is equals to of x of n minus of f of xn divided by f dash of xn. Till this point, probably each and everything must be clear to all of us. Yes, I don't find any difficulty the people will have till this point. Once you are done with this, probably there is no doubt has been left out. What I would be doing now, I would straight away be jumping towards the method of solution. See, f of xn, f of x is clearly known to me. Which has been x cube minus of x minus of 3, and as we have been searching for x of n, so all of x would get replaced with x of n. Yes, so f of xn is clearly known to me. Next goes the differentiation of f of xn. Obviously the differentiation of x cube of n would be taken place. That would be simply equals to of 3x square of n minus it would become 1. So x of n plus 1, which is the next approximated value, would become x of n minus of f of xn, which has been xn cube minus of xn minus of 3, and at denominator you will be having 3xn square minus of 1. Either you can take its LCM, and once you will be taking its LCM, definitely towards denominator side you will be having 3xn square minus of 1, and it would get multiplied with this, and definitely numerator would be bit simplified. And now you have to find the approximated value after the two approximation. So what you are going to do over here, definitely at very beginning you are going to take the reference of x naught. You are going to take the difference of x naught, and the x naught has been 2 over here. And once you take the reference of x naught, if you are keeping x naught over the place of xn, by default you are calculating x1. Similarly, you would be going into the next iterative process, where instead the x of n you would be feeding x of 1, and once you feed x of 1, by default it becomes x of 2. So taking the reference of x of 1, whatever you get from here, you would be able to get the value of x2. And you yourself would be able to see. The same thing has been happened. I fed in the value of f of x naught divided by f dash x naught, which was 3 divided by 11. The first value of the iterative value has been found to be 1.727, and similarly once we are taking the second iteration, I got the value of x2 as 1.6736. I need to get the value till its second decimal place, and hence the most answer is going to be 1.67. So I would expect from each one of you, they must be able to by heart this formula. X of n plus 1 has been x of n minus of, yes, even you have a little bit idea, a little bit confusion, you can by heart from the different methods. See, my dear friends, x of n plus 1, whatever the unit you have with the x, no, towards right hand side both of the terms would have the same unit. Yes, the x of n would have the same unit as x of n plus 1. Sometime it could be distance, sometime it could be time, so on and so forth. Now if you will be discussing about the f of xn, and at denominator side is gonna be f dash xn, the differentiation would take place with respect to the x again. So obviously the unit of f of xn would be smashing each other, and the xn would come towards upside, and it would also have the same unit. Obviously it is satisfying the requirement of the units also, because many of the times the student used to recall this formula as f dash xn divided by of f of xn. Such a blunder they are doing. If you recall this formula as f dash xn divided by f of xn, tell me what would be the unit over here. Obviously the unit of f of xn would be smashed out, but the unit of xn would come towards the denominator side, where the unit of xn is coming towards numerator as well as numerator. Definitely left hand side and right hand side units are not getting matched. Whether you use physics, whether you use mathematics, definitely you should follow the method or concept of the unit. You cannot go beyond it. Could you understand what I am saying? So I would just request to each one of you, if you do not want to by heart this formula, just have the patience, and you can follow one step, what it is, and that's the step of Taylor series expansion. The first approximation has been the approximation around x naught. So what I did, I assumed, let's take the h has been the deviation from the x naught, from where I would be getting the actual most root. And if you are getting the actual most root, the value of the function at that moment of point would become 0. And what used to be the series expansion of f of x naught plus of h, that would be simply f of x naught plus of h f dash of x naught divided by 1 factorial, so on and so forth. I have taken the linear approximation of the Taylor series expansion by just assuming the h is very nearer to the value of x naught. From here I got the value of h, and the h has been minus of f of x naught divided by of f dash of x naught, and hence the first approximation x1, which is equals to of x naught plus of h, would be x naught minus of f of x naught divided by of f dash x naught. Such a least amount of effort we put in just to find the actual equation. And yes, what would be the next step if you go into the better approximation, or if you're interested finding the value of x2, so rather taking the reference of x0, you would be taking the reference of x1, and hence it becomes x1, x1, x1. Or in short, if you take the reference of x of n plus 1, or if you wanted to calculate the better approximated value x of n plus 1, you can take the reference of x of n, f of x of n divided by of f dash of x of n. That's it. That's it. So tell me, from here onwards, really you had to by heart this formula or not? If really you had to by heart this formula, from here onwards, you just say yes. And if you think from here onwards you need not to by heart this formula, you can just write no. So at least I'll have a fair idea whether you guys are really understanding the basic concept behind this formula or not. Yes. Yes. In the same sequence, I am going to take the 9th question, and this has been the problem from the concept of the Laplace transformation. Let me read the problem thoroughly and we'll try to smash this problem out. And yes, it has been a simplest form of the problem. If the Laplace transformation of f of t is given by s plus 3 divided by of s plus 1 within the bracket s plus 2, then we need to find f within the bracket 0. What does it mean by the f within the bracket 0? My dear friends, the f has been denoted as a function which has been a time domain function, and hence the f within the bracket 0 indicates you need to find the worth of the function at t is equals to 0. Nobody should have any doubt, because many of the students would think that they want to calculate the worth of the function at s is equals to 0. No, my dear friends, it has been the worth of the function at t is equals to 0. It has been the worth of the function at t is equals to 0. See, let's take, we had a function in time domain which has been wrote as f of t. Its Laplace transformation has been written as f of s. Why we write bidirectional arrow? Because it has been a lossless transformation. At any moment of time, you can switch from the time to Laplace and Laplace to time without losing any information. It has been clearly given. We had selected a time domain function whose Laplace transformation was clearly known to me as a s plus 3 divided by of s plus 1, s plus 2. And we are interested finding the worth of the function f at t is equals to 0. And in short, we can say when the t is approaching towards 0. Yes. And here we can use the final value theorem. May I know what used to be the limitation of the final value theorem? What is the limitation at which the final value theorem cannot be applied? We had to search over the degree of numerator and degree of denominator. If we'll talk about the degree of numerator, the highest degree of s has been 1, and similarly once we'll be talking about degree of denominator, the highest degree of s has been 2. Keep in mind, the initial value theorem can be applied only and only if degree of denominator is greater than the degree of numerator. Why? This is not the right time to discuss about why. Otherwise, when we explain the things into the great detail, definitely we also go into the detailed analysis of why we do so. Could you understand what I'm saying? So as far as this problem is concerned, degree of numerator has been 1, degree of denominator has been 2. Obviously, it has been satisfying the requirement of the initial value theorem. The initial value theorem is bingo. Yes, ready to use. What used to be the initial value theorem? So here it goes, limit s tends to infinity, s times of the Laplace transformation of f of t, which has been clearly given as a s plus 3 divided by of s plus 1 into s plus of 2. Yes. Yes, no? So what I would be doing, the s would get multiplied. As the s is getting multiplied towards numerator side, numerator would be specifically become s cube divided by, not s cube, it's s square, no? It would become s square plus of 3s, and at denominator it would be s plus 1 into s plus 2. If you want, you can multiply them together for the better understanding. So it becomes s square plus of 3s plus of 2. Yes. S square plus of 3s divided by of s square plus of 3s plus of 2. And now once I would be feeding limit s tends to infinity, obviously it has been a property of the limit. if the limit is tending towards infinity and towards the numerator and towards the denominator, if the degree of the polynomial has been same, the result would be a constant value. Result would be a constant value. It can't be 0. The D has been ruled out. D has been ruled out. How will you feeding the data? First, the highest degree would be taken common from the numerator as well as denominator, which would be s square from the numerator, which would be s square from the denominator. They would be cancelling out. So the component which would be left out is simply going to be 1, 1, and here it would be 3 divided by of s, here it would be 3 divided by of s, and here it would become 2 of s square, 2 of s square. And once you will be feeding s tends to infinity, definitely this factor goes out, this factor goes out, this factor goes out. So end of the day, the result what we have in our hand is simply going to be 1. So the best most answer for this problem is simply 1, simply 1. Anyways, let me move forward into the next question. We are going to take the next question from the page number 40. Page number 40. Let me go forward. 40. Yes. See what the problem states, and probably you would be able to smash this problem within a small amount of effort, because it has been a problem of trapezoidal rule, and in yesterday's class probably we have taken the 2 number of problems based on the trapezoidal rule, and even we derived the basic theory behind the trapezoidal rule, from where the complete formula itself have come out, that even we have derived in the last class. So the agenda behind today's video, although I would be taking this complete problem, but I am going to solve this problem with the just result. So here the values of the function y of x at discrete values of x, obviously the values has been given discretely, for x within the closed interval of 0 to 10 are given in table using the trapezoidal rule, where the integration has been taken place from 0 to 10, y of x dx is equals to 0, y of x from 0 to 10 dx is equals to 0. Anyways, once you'll see discretely at the different values of x, the value of y of x has been given. Y of x has been given. May you know how many number of steps we have chosen? 0 to 1, that would be 1 step. 1 to 2, that's going to be 2. The total 10 number of steps we have chosen. So if you'll focus over this problem, if you'll talk about the number of steps which we have chosen for this particular table, it has been 10 number of steps. 10 number of steps. Yes. If you'll talk about the step size, it has to be a uniform in nature. What about the step size which has been chosen in this problem? My dear friends, the first value of x was 0, and now it was spuriously went it to the 1. From 1 to straight away jump it to 2. So if you'll talk about the step size has been uniform and has been 1 now. Has been 1 now. And as you have been interested finding the integration of f of x which follows this table from 0 to 10, tell me what would be the best most answer. The answer used to be h divided by of 2. Within the bracket, you used to have the addition of starting and the last data, starting and last data, plus 2 times of the rest of the data, which are the data in between. That's it you have to do. What is the worth of h? H has been 1. So simply 1 upon 2 has to get multiplied, whatever the result comes out from this calculation. What's going to be the starting and the last data? The starting data has been 5, the last data has been 30. So simply it's going to be 35. And there you had to add the remaining data, which used to be, yes. Could you understand? You have to feed this data over here and you will be getting the best most answer. Anyways, I have the solution also. So you can have just a glance over this solution. See, we had h divided by 2, the value of h was 1. Similarly, we had the first as well as last data, which was 5 and 30. The 2 was getting multiplied with the rest of the data, obviously, which was apart from the first and the last data. So it was 3 and getting stuck at 18. So end of the day, the result what you got from this particular problem has been 33.5. 33.5. Yes, let me take the next question in the sequence. Yes, it has been a utterly well designed problem, and I feel many of the students may not have solved this problem completely. And this problem has appeared in chemical engineering recent year, that's year of 2021. An ordinary differential equation ODE, obviously dy by dx is equals to 2y, has been an ordinary differential equation because the coefficient of the derivative which has been used is nothing but ordinary in nature. with an initial condition y of 0 has been 1, has the analytic solution y is equals to of e to the power of 2x. Using the Runge-Kutta second authored method, numerically integrate the ODE to calculate y at x is equals to 0.5 using the step size of h is equals to of 0.5. If the relative percentage error, anyways, they have clearly given the definition of the relative percentage error. If they are not being given, then also you must have the clear cut idea about the relative percentage error. Here it used to be true value minus of calculated through the numerical method divided by the true value. And anyways, if you calculate the value through the analytic method, definitely that used to be the true value only. So what used to be the percentage error? That used to be y of true value, y of approximated value. The approximation would be done by any of the numerical method. In this case, the numerical method which we have used is nothing but the RK method, divided by y of true value, which would get multiplied with 100%, Agreed? So many of the students may have a little bit doubt over this formula, sir, from where this formula have come, my dear friends. The analytic method means rata-rutaya method. That means while using the solution of the differential equation with the help of variable separable Leibniz form, the linear differential equation, homogeneous, whatever the result you get, no, that used to be the precise most result. They are not the approximated result. So with the help of those methods, whatever the result you get, that's nothing but the true value, or I can say analytic value. So true minus of approximated divided by of true. Once we take its mod, why I am taking mod? Because the value would always be calculated positive, and now the 100% has to get calculated, multiplied. 100% has to get multiplied. Yes. So here the complete process has to be followed. So I expect you guys are having a bit idea about the Runge-Kutta's method of the order of 2. Yes. What we do there, obviously, as it has been clearly given, it has been the Runge-Kutta's method of order of 2. So 2 arbitrary constants we calculate. That first is K1, the second is nothing but the K2, and the K used to be the mean or the average of both of the Ks. Yes, we have got that. And end of the day, the numerical value which you have calculated, it's simply going to be 2.5, and the analytic value is already calculated as 2.718. How? Because it has been clearly given. The particular solution for this given differential equation has been y is equals to of e to the power of 2x, yes, e to the power of 2x. So that is why the x has been fed as 0.25, and whatever the value we got now, that has been the true value of the function y at x is equals to 0.25. And here the value which we have approximated at x is equals to 0.25 has been the approximated value using the Runge-Kutta's form. Yes. We are going to feed both of the values, we'll be getting the bestmost answer. So probably till this point, each and everything must be clear to all of us. In the same sequence, we are going to take the next question. Yes, it has been a well-designed problem, and we are going to smash this problem here itself. See what this problem states. For the ordinary differential equation, yes, it has been ordinary differential equation because all of the derivatives has been ordinary form of differential. With the initial conditions, has been given as a y of 0 is equals to y dash of 0 is equals to y double dash 0 is equals to y triple dash is equals to 0. My dear friends, why they have gone till triple dash? Because in future, once you will take its Laplace, no, probably once you take the Laplace of any of the derivative component, you must be knowing how it looks like. Once you will take Laplace of d cube of y of dt cube, you will see, you will be starting with the y, s to the power of 3 y of s minus of s square y dash naught, similarly y double dash naught, y triple dash naught. So as far as the Laplace of the first term is concerned, no, you had to deal with the y of naught, y dash of naught, y double dash naught of, and similarly y triple dash of naught. Similarly here, similarly here, similarly here. And they have been precisely given as 0. That means the people who are from the electrical and electronics must be able to appreciate easily I can apply the transfer function approach. What it says, I can take Laplace both other side. Once I'll take the Laplace of 1, it becomes 1 upon s. Here it's simply going to be s cube of y of s, s of y of s, similarly 11 of y of s, and here it becomes 6 of y of s. Yes, no? Here it becomes s cube of y of s plus 6 times of s square of y of s plus 11 times of s of y of s plus 6 times of y of s is equals to of 1 upon s. And I know many of the students would have tried this problem with the help of CF and PI. Yes, you can do, no issue as such, but the calculation would become very tedious, very complex, very, I can say, tougher inside. So the problem has been given in a form of ordinary differential equation, but it was quite soon. They wanted you to solve this problem with the help of Laplace application. So we'll take the Laplace both other side. The first term would give only s cube of y of s. The second term would give only 6 times of s square of y of s. The third term would give 11 times of s times of y of s. The fourth term would give 6 times of y of s, and the right one most would give 1 upon s. End of the day, you will be keeping y of s one side and you will be keeping all of the component towards denominator side. Yes. And one of the best thing regarding this problem, see what they are asking. They are not asking you to get the y of t. They are asking you to get the value of y of t when the t tends to infinity. My dear friends, the value of y of s has straight up been calculated. And as you have been finding the value of limit t tends to infinity y of t, easily you can apply the final value theorem, which used to be limit s tends to 0 infinity s times of y of s. And once you've done so, the answer what you are getting is simply going to be 1 upon 6. Yes. So I would say the problem which have appeared in year of 2021, all of the questions has been taken in total 14 number of sequence of the videos. So I would suggest to each one of you, if you really wants to know which kind of the problem has been appeared in year of 2021, which are the domain were focused more, which are the topics were focused more, what was the distribution of the marks, you should follow all of the 14 lectures which was taken from today till 13 days back onwards. Could you understand what I am saying? So you will have the fair idea recently which type of questions are getting framed. And as far as the problem is concerned, I have taken all of the problems, whether it belongs from electrical, electronics, mechanical, civil, electrical, instrumentation. So you have the chunk of the problem with the help of which you would have, or you could understand the psychic behind the problem which get designed into the gate electrical engineering, instrumentation engineering, electronics engineering, mechanical, so on and so forth. So from tomorrow onwards, we would start a new series probably over the engineering mathematics. I will let you know with the help of thumbnail as well as the video which I used to post over the different Telegram groups and different Telegram channel managed by Gate Academy. And end of the day, before completing this video, I would suggest to each one of you, our AE and JE courses has already been launched. Our classes are going to be start from tomorrow onwards, and today night till today's night, the cost of the complete package is just 7,000 including GST. If you're interested, you can just hog on and you can purchase today itself. From tomorrow onwards, the price would increase. Okay then, probably you could have enjoyed this 14 lectures over the engineering mathematics where I have smashed all of the problems which have come in recent year. We'll meet with the next agenda from the next video onwards. Till then, bye bye, take care, good night.